All right. All right, all right, all right, all right, all right. Looks like we lost half of the human beings in this theater. Calling all human beings in the vicinity, come back to this room. Those of you that are robots also return, but I'm assuming you're actually on time, so. Oh, I see, there's cake. That's what's going on. It's really hard to compete with cake. One by one. Can you hear from outside? I apologize to everyone watching the live stream that there is no cake for you. If you would like to prepare yourself a piece of cake at home, you can feel the full DConf experience right now. You are missing out on cake, Ethan. Can someone please bring some cake for Ethan? That would be much appreciated. We did have a request from the live stream that there be VR next year to create a 10 out of 10 immersion experience. So we're taking suggestions from those of you who are here. Where should the 360-degree cameras be placed? On stage, in the crowd, nearby the cake? Right next to Amory, yeah. Okay. Do we have like 75% of the people? I think so. So you might recognize Ethan from last year. If not, he works in the video game industry. He's from Remedy. So I'll let him tell you what he's going to be talking about today. And with that, I'll get off your stage, Ethan.
Am I on yet? Hello, now I can hear myself echo. Hello, Berlin. Hello, hello, we're all awake. Good. And is this the internet in here, guys? Hey, internet, how you doing? All right. So before we get started, well, the title of the talk is Binderoo, a rapid iteration framework that even scripters can use. You might see a little URL up the top there. Oh, I've got cake. I'm not going to eat it on stage, all right? This is just for later. So there's this little URL up there, and what you can do is you can enter that into your devices, load it up. It's just a Q&A thing. You get to ask Twitter-length questions. You can upvote them. And at certain points throughout this presentation, I'll flash some up on screen and answer some questions as I go. And there's already one up here, in fact. Is this thing on? Yeah, it looks on. So all you need to do is go there and ask, and we can deal with it that way. Cool. So for those that do not know me, as the title slide gave away, my name is Ethan Watson, and I come from the fictional land of Australia. I've been in the video games industry for about 14 and a half years now, during which time I've shipped games on 11 different platforms. And I've done that both as an engine programmer and as a game programmer. And there's just a selection of the games I've done up there: the Tasmanian Tiger 2, Star Wars The Force Unleashed, Game Room, which was an emulator thing, that was great. And most recently, at my current job, we shipped Quantum Break last year, which was the first AAA game to ship with D code in it, I believe. Yes, I am also no stranger to DConf here, neither is Remedy. Like I said, I presented here last year, and Manu also presented here in 2013 about the initial work we did to support D. Now, I have been a little bit busy since then. I presented a talk at the Game Developer Conference Europe event held in Cologne last year, and that talk was very well received. Unfortunately, it was scheduled opposite John Romero, who co-created the original Doom back in 1993, so the audience just a little bit smaller than I would have liked. It was very well received, though. It got like a 4.5 out of 5 rating, which was well into the way above average section of it. I also presented at a conference called Reboot Develop in Croatia last week, which literal industry legends were there and all mingling around. It was great. The talk was also quite well received there. Now, the interest in using D in game development is certainly increasing. I'm hoping in part it's because I'm getting out there and getting the D word out, which means I am talking to other professionals in the industry, and I get to hear some of the reasons why they haven't quite picked it up yet, or they're not quite ready to pick it up yet. There's one in particular that keeps on cropping up, and the whole idea that D needs a large corporate sponsor. Just the other week, in fact, I was talking to a guy from IO Interactive. They do the Hitman games, if you've played them. They're quite interested in what Remedy's doing with D, but skeptical because of, the lack of a big corporate sponsor. Swift has Apple, Rust has Mozilla, Go has Google, et cetera, et cetera. And yeah, I did mention this to Andre yesterday, and he's confident that this will be solved. So as soon as that's solved, it's going to make my life easier getting the word out as well. All right, so our usage, though, we didn't bother waiting for that. We thought, yeah, D's great, let's give it a go. Before I joined Remedy, the programmers decided that they wanted a system that enabled rapid prototyping. And after some discussion, the decision was made to try D, but compiled into a DLL. And that introduced a concept known as code as data. It's not something that you compile and be done with. It lives inside your data directory with all your other assets like textures and all that. If you're familiar with Unity, similar kind of model there. The solution that we had in Quantum Break, prototype quality. It was started by Manu before I joined, and Remedy, and when he left, I overtook his work, got it to a functional state, and it was prototype quality. There were problems. But we're now a multi-project studio. We're also announced that we're doing a PS4 game, so we're definitely going to be multi-platform as well. So now that we're doing this, let's do it right. And we're doing it open source. You can go to that URL up on the internet right now, in fact. And I've been pushing code to there regularly. I will be talking about this software that we're developing here today. And like I said, we're also looking at doing PlayStation 4 support. So there's also people around that are interested in Linux and OS X support, and it's an open source project, so if you'd like to contribute, I haven't set pull submission guidelines up there yet, but if you're interested, come talk to me. Okay, Binderoo itself. There's 3 important goals that I am aiming for Binderoo. The first one is that we need perfect C++ binding. So it's kind of unreasonable to say to people, hey, here's D, it's great, it's new. Oh, but you can't use it, you have to throw away your old code. That won't work for anybody. C++ is our de facto language in the AAA console space. Thus, if we want to use D and introduce it gradually, it needs to sit on top of our C++ code. So binding C++ perfectly to there is the primary focus to begin with. On top of that is rapid iteration. Now, these days, your Xbox One, your PlayStation 4, it has 5 GB of RAM that it's got to constantly fill up to do the games that you want to play these days. It's unreasonable to start and stop your program because you want to make a little change. So it literally takes you a couple of minutes to get back to where you were testing previously. So we absolutely need to be able to rapidly iterate code on the fly. And a lesson learned from doing it all before on Quantum Break is that it needs to have minimal maintenance. Programmers are lazy by definition. It is literally our job to tell a computer what to do so that we don't have to, all right? So if we make a system that a programmer doesn't really have to maintain, they're absolutely going to use it. So perfect C++ binding is a bit of a tricky one. D does have quite a few features for binding to C++, but things in C++ are rarely simple. Like if you wanted to write code like this in C++, that's a bit blurry. Can you make that out well enough? Can't really do much about it anyway, but that's just instantiating an object on the stack and printing a value from it. That's cool. You'd expect that to work. If you were to write an equivalent like that in D and you were using it as a class, you would get a bit of a null pointer error. And that's because classes are reference types there. You have to explicitly instantiate them. So if we wanted this code to not throw a null pointer exception, we'd have to go ahead and allocate an instance of it. And that's kind of an important thing to keep in mind, because if you want to bind a C++ class, you have to use D classes to do it. But it gets quite tricky with more complicated types. So we've got a C++ bound class there that embeds that some simple class we're just using. And that would be fine in C++ code, but, surprise, what you've actually got here, because it's a reference type, is a pointer and not a complete representation of the object. So your binary layout is immediately ruined. There's also one other surprise hiding in here. Regardless of whether your class has virtual functions or not, a virtual function pointer will get added into your class there. That's all kinds of bad for us. And that's kind of an inescapable piece of language design. You know, in C++, there's essentially no difference between a struct and a class. Both of them are, in fact, value types, as in the storage location is defined by the user. D has taken a far more modern approach there. The struct is the value type. The storage location there is defined by the user. But the class is the reference type, with storage defined by the language itself. Now, there's ways around that with classes, but they're all kind of broken and fairly unintuitive. And for this system to just work for programmers, it just needs to just work. You've got to not think about it. That got me thinking. All right, so D structs are value types, just like C++ types. So if they're the closest to C++ types, maybe we should just bind it all up in structs. That sounds reasonable, right? Yeah, if it wasn't for the fact that D structs can't have default constructors, virtual methods, or inheritance, you know, they'd be quite perfect. But, you know, don't despair. All is not actually lost here, because Binderoo is meant to be a rapid iteration system. If code being treated as data, that means our D code is going to get compiled into dynamic libraries. And that's a practicality for two reasons. If it were compiled into static libraries, then we'd have to statically link the executable every time. Can't do that. Being a dynamic library also means that we can unload it and replace it with a new version at runtime, thus supporting our hot reloading concept. Now, Windows DLLs. You can use them in a static manner these days. When you compile your DLL, it spits out a little lib that you can link into your main executable, hides up all the function linking behind the scenes. But we can't do that. We're using the load library functionality. So we've kind of got to do all the binding ourselves. And that leads to a common solution here that solves our interoperational woes and handles function linking automatically, which I call, let's implement C++ virtual tables from scratch inside D structs, and also let's make sure non-virtual methods work and inheritance works, and let's do it in a way that we can collect that information at compile time and use that to link functions on library load and support hot reloading through automated type serialization, and also, while we're at it, let's support version numbers on functions and objects to also solve Windows DLL hell. Those cows, I tell you what. Now, I've got it marked up here for checking questions, and it looks like we do have one question here. Have you seen the talk of Jonathan Blow? What do you think of his Jai language? I'm going to get to that into a bit, because at Reboot Develop, I spoke to Jonathan Blow quite a bit, and we've actually got quite a lot of common ground we can talk about. So we'll get to this. But as you can see, the question feature works, so please ask more questions. Okay, so to handle our rapid iteration requirements, Binderoo itself is split into three major components. The first one is called the service, and that's embedded into our content creation tool. What the service does is it monitors our source data directories for code changes and is responsible for recompiling that code into new libraries. And that needs to communicate to the host, which is the component that gets embedded inside the game executable. And it will receive notification about these new DLLs, reload them, link up all the functions, and handle all the object lifetime concerns. The DLLs themselves need to include the Binderoo client code, and that handles all the messy host communication, and it's also the API for Binderoo, and this is what we're going to focus on for a little bit. Okay, so you're writing a client DLL, and you want to know how to use your C++ code. There's a few things you need to do in Binderoo to make this work. They're all quite simple. So we've got our struct representation to start with, and what we need to do is apply this little UDA up here I've got called cTypeName. That has several uses. When we're trying to bind functions for looking up, we don't use the name of the D object. We actually use the C name for it, which gives us complete namespacing into the C++ types, and that's kind of useful for a few reasons. So as such, the first name is the fully qualified, the first parameter of the cTypeName is the fully qualified C name of your object, and the second one's a little bit more interesting. We give it the location of the C++ header as your project would expect to find it, and this will come in handy later. So this is the next part about C++, you know. What's a C++ class without some functions, right? So we've got some virtual functions up there, and we just tag it with the bind virtual UDA. And that one there has a numerical parameter, and that's basically the version number that this function was introduced into it. It secretly takes a second parameter that defines the version number that the function was removed from. Non-virtual functions, essentially the same thing, except you use the bind method UDA to bind it. And finally, there's a little bit of magic to make it all work here, which is we use a couple of mix-ins. The first one that we use is the mix-in template. That replaces, what have I got here? So what this does is it sets up things like the constructors internally, and if you've defined that begins virtual as a yes, it will also go and insert the virtual function pointer inside your class. The second one is a string mix-in, and this one is responsible for the batch of work I'm going to describe next. So what we need to do is iterate over all members of our class looking for the functions. There are many ways to work out whether you're dealing with a function in an object here. The easiest I've found by far is to just use get overloads on it. If it's got a length greater than 1, clearly you're dealing with a function. So that's pretty handy. And each function we encounter, we need to do a few things with it. The first is to define a function pointer type. So we effectively need to rewrite our functions to both have C++ linkage and to also follow the this call convention, which, at its simplest, you can say, okay, your first parameter of your function is actually the this pointer. So we just need to build up a new type based on that. That's all cool. Of course, being a game development engine, a lot of our functions return by ref. So if you were to just go and blindly define your function pointer type like that, that actually kind of gives you an error because specifying the ref return parameter is a bit of a, it's got problems, I guess is the best way to put it. You can't do it like that. So what you need to do is solve it with templates. So the template essentially takes an alias to the function that it's trying to rewrite. It'll do some parsing on it. And what it'll do is effectively rewrite a new prototype out like that, not as a function pointer, but as a function declaration. So this seems all right. You just take the type of that, and it seems all cool, but it's not quite foolproof at this level because this template, it will live in a module somewhere, and it will deal with types that don't live inside this module. And this has kind of become a problem with all the template visibility changes over the last, year or two that's been tightening up, because it leads to some really awful code that I'm not happy with. Each and every type that is a return type or a parameter to this function, I need to analyze it. And if it's a user type, I need to get its module name and mix it in. And that's, otherwise it just errors out complaining that this type is not visible. And, this kind of really frustrates me because any kind of template like this that deals with types in a non-trivial manner now needs to go through and do this. It kind of makes me not want to use templates so much, but at the minimum, I've got something that works now, so I can move on and continue with my life. So anyway, you've got your function pointer type after jumping through these hoops. Cool. Now we need to stick an instance of it somewhere and mark it up with this new secret UDA that our binding system actually looks for. This is the bind raw input UDA, and I've not really gone into the details of what's stored in there. It's just every single little bit of information the system needs to work out what function it actually needs to stick in this pointer. Now, the final thing we actually need to do is provide an actual definition for the function we're binding, because it's just a declaration by itself. And this is one of the primary purposes of this mix-in. It will generate the function for you and simply wrap it to the function pointer that it's stuck somewhere. And doing it like that, especially with the versioning, means that we can hot load it. If it's loaded into an old version of the engine, we can handle that. If it's loaded into a new version of the engine and it's old data, we can also handle that with a bit of a logic. You'll need to write that a little bit manually, but it's cool. It's fairly usable. Methods are also handled in essentially the same manner. Instead of jamming it into a virtual function table, we stick it into a method table, which just doesn't pollute the virtual table at all. And this is where it gets fun. Derived types are also quite easy to implement. We simply just use a different mixin template, the CPP structs inherits template. And it just takes a parameter, which is the base type, and all it basically does is insert an instance of that base type into that class and alias this to it. And then it also takes it into account for generating the bindings and all that. So you end up getting quite a good replication of a simple inheritance chain that way. I've not bothered about multiple inheritance at all yet. There is one other type we need to care about. So, what's the point of going to all this trouble if we can't write new code with this system, right? We're writing a rapid iteration system. So we need to write new code, and it needs to just work. And that's where we've got this little destruct inherits mixin. It essentially operates in the same manner as the CPP struct inherits mixin, with one important distinction. Each bind virtual method encountered, it will jam that into the virtual function table. It's no longer trying to fill function pointers. It's now trying to pull functions into this table. So you can instantiate one of these classes and use a C++ interface on it, and the C++ code will just merrily run decode. That won't be any wiser to it, which means I can write my code, it will rapidly iterate, and I can get on with enjoying my life in D-land. Excellent. To tie it all together, though, you need to expose all your C++ functions to this system. Now, the method we had in place for Quantum Break, which I went into last year, that was awful, right? Anybody remember that? Ugh. We're in the future. This can be automated. Now, I've been spending an awful lot of time with mixins and all that generating decode, and that got me thinking, using all my knowledge here from compile time introspection and all that, I should be able to generate C++ code as well, right? So this little process here is a fair bit more manual than the decode, but you can also effectively automate the exposure of C++ functions too. So the first step here, this is actually a part of our compile chain at Remedy at the moment. You compile all your D definitions into a DLL. And then, as a post-build process, you need to invoke a program that I distribute with Binderoo, which is called the Binderoo util. It has a little parameter there that will load up your generated DLL and invoke a function that will ask it to generate some bindings. And I thought it was going to do that. That's a screenshot of just a really small snippet of the bindings it generates. So trust me, it works, and it looks fine on a good display. But at the very least, it will generate a CPP file, output it to the disk somewhere, and it should be pretty obvious for here. You add the CPP to your project, you compile it, and that embeds it into the host, and you run it. Simple. If everything's been set up correctly, it just works. It's great. There is one major feature that I do have plans for in the future. I want to be able to pass header files and auto-generate the D definitions as well, but that in itself is a massive undertaking, and that's quite a way off. All right, so this is one of these things, and this gets to the Jonathan Blow thing here, because at Reboot Develop, I did have a few good conversations with him. Now, if anybody's not familiar with Jonathan Blow, he's done video games that are well received called Braid and The Witness, but most people here would be interested because of his programming language called Jai that he is working on. And, we did have quite a fair bit to talk about that was in common. Like, we've both had Jack of C++, and we want a better way. Jai itself is kind of coming along well. It's got three things that I use quite a bit in decode. Compile time code evaluation works, code generation at compile time works, and he's got complete introspection running. Now, this is where things start to differ with him, because his philosophy as a programmer can essentially be summed up with this sentence up on the screen. I just want to write code. And he's basically writing his own language so that he can just write code. And this is something I understand, because every time I have to battle with a language to get it to do what I want, it's kind of a frustrating experience. And I've had to battle quite a bit with D's compile time functionality to get this to work. So the binding stuff that I just described here is actually the second implementation of the binding system. I haven't pushed it all to GitHub yet. It's sitting on my laptop over there. I originally had it as one mixin template, but I honestly don't know how that works after I dug into it a little bit longer. But there's things that happen at compile time that make it a little bit trickier, like invoking traits all members will finalize your object, so to speak. So if I want to iterate over my object to see if it has virtuals so that I know whether to stick the vtable pointer into my object, that finalizes it, which makes it impossible for me to stick the vtable into the object. Hence why I have to explicitly specify that we're starting a vtable now. Supplying that type to a template parameter also finalizes it, which kind of means that the original mixins, I don't know how they worked in the first place, but it's also something I abuse in places in my new code. So, you know. I've also been working with Stefan over there, providing him sample code that compiles with Binderoo. And as a result of this, I found out that the templates engine and what I was doing with the templates is really quite slow. Now, my original intention with the binding system was to write code that humans could read and understand. But instead, to get performance out of the system, after Stefan's recommendations, I've had to rewrite it to not rely on templates, but to generate code for string mix-ins to get the same functionality, which makes it significantly less readable. Yeah, not too happy with that, but we do get better performance out of it. Also worth pointing out is that compile time debugging is fairly awful. We all know it, but especially when I'm dealing with mix-ins and all that, my only debugging options most of the time are to pragma message my output and try to correlate what the compiler is telling me with what I've been generating. So yeah, I would like a solution to that at some point. I think Stefan has some ideas for that as well, so I'd be very interested to see what he gets up and running there. I also need to write some de-improvement proposals to both help facilitate the perfect binding and to help them just write code without having to worry about the implementation details. The first one I need to write is about R-value reference parameters, and this is something we have relied heavily on in the games industry for a very long time. This is just a very basic example, like a large chunk of our math is multi-dimensional, be it three-dimensional vectors or matrices, usually 3x4 or 4x4. These are fairly big objects ranging from 12 to 64 bytes, even more if you use double precision, which we basically don't at runtime. We do that at source time, but not runtime. So copying these values to a stack just to call a function is inefficient. So we always pass these types around by reference where possible, which leads to it's led to people doing lots of shortcuts over the year. This is something that just works in C++. You invoke your function, inline declare some versions of the variables. This is just initializing the matrix to identity, but indeed that will refuse to compile. There is a way around that, which is you generate wrappers for your function there that will take each parameter by value in differing types, but that leads to a permutation problem that very quickly gets out of hand. So having a nice way to define that will be the aim of that dip. Further on top of that, though, is that to get this perfect C++ binding happening, we kind of need default constructors to be able to work. Now, our C++ programmers, they expect to be able to instantiate their objects on the stack like this absolutely awful example that nobody in their right mind would ever write. It was just a really quick example I could throw up. So what this one does in particular here is you can see I've kind of highlighted a mutex up there, which is a binding to our C++ mutex object. And what it does on a construction, being like in the Windows API, it will call initialize critical sections so that we have a valid mutex to lock and unlock. The workaround I have for this at the moment is kind of awful, and I know somebody, I can't remember who on the news groups didn't like that I was doing this, but we use the static brackets operator to call the constructor for bound objects. And you know, it works when you're doing it like this on the stack, but you know, again, things in C++ land are never that simple. Perfect C++ support means we also need to be able to embed these objects inside other objects. And if you embed a mutex like this inside your object, you can't post-split that. It absolutely needs to go through a construction phase. And there are instances like this in Remedy's code where we embed things like mutexes or semaphores or other complicated types with non-trivial constructors that we kind of expect to just work. So it absolutely needs to write up a dip there and see if I can get something rolling there. But this next one, not exactly a dip, but core simmed is effectively unusable by LDC or, you know, ARM platforms as well. which means now that we're getting into PS4 support, and that is an LLVM toolchain, I need to have LDC support in there. And we use sim data types quite a bit. Now, I know Manu is working on a standard sim module that was going to deal with this, but it's not done. So as it stands right now, I'm going to have to do a workaround for that just so that our programmers can just write code. Okay, so I've just gone on a bit of an info dump, and I've got another spot here to check questions, and there's one. Is the order of mixins significant? Yes. And that's because of the finalizing of the type there. You need to be able to insert that vtable pointer before you start passing over it to see if you've got virtuals that need to go into that vtable. And like I said, I absolutely have no idea how my initial implementation worked. It was one mixin, and it had multiple mixins inside it, and somehow it Frankensteined its way into a really slow compile time that worked. But it was unsuitable for many reasons. All right, so I'm going to need to take a little drink here, and then we will continue. All right. So back at the start of this presentation, I mentioned that our programmers wanted a scripting language of sorts, and because programmers wanted this, I just started thinking, what about everybody else? Why limit this to the programming team? Just about every other team involved in gameplay requires scripting capabilities of some kind. And it's really got me thinking, what's the point of running a script VM for some language when we have code that is treated as data? Now, we already had a scripting solution in place, and those that heard my talk last year will know a little bit about it, because I mentioned that it's been around since Max Payne. It's shipped a few games. It's definitely battle-tested. There are many things that are not ideal with it. Executing code-provided functions is actually message-based. One function receives a message, and there are these awful if-elses everywhere that do string comparisons to work out what you actually want to do. Now, the big problem there is that there's no debugger. Not insurmountable, but it basically means we need to write one if we want to support it even more. But the big red mark against it is that it lacks modern features like loops. No, seriously, you don't want to see the hacks that they use to get around this limitation in Quantum Break. It's truly awful. But like I said, we are in fact totally in the future now. We're well past 2015. If we want our scripting language to be usable, we'd have to invest quite a bit of effort into getting it up to modern standards, or we can just replace it with an actual programming language. Now, interestingly, our level team is quite keen to be let loose with a real programming language, but, saying let loose kind of does them a disservice. Several of them have computer science degrees. They already know how to program. And even if they don't have a comp sci degree, they already know how to program otherwise from playing around with Unity. Our level team and every other team these days, they're quite highly skilled, so the old assumption of not giving these people enough rope to hang themselves with, it's just plain wrong. And this is one of the interesting things. After discussing with the team, they're also kind of keen to try multi-threading out. So we've been replacing our old engine behind the scenes for a while. They used to have all these old monolithic game objects that execute single-threaded. They were kind of awful. We've been pushing for component-based game objects, and the new ones we're writing are being designed to run asynchronously. So rather than have a monolithic script VM that executes and blocks the entire thread system from running, these would just be function calls that we can call during our tasks. And yeah, I said to the level team, it's like, you'll have to program a little bit differently. There'll be a few restrictions, but you can do more than you always ever used to be able to. And they were like, we can do more? Sign me up. So, yeah. And after asking around, I haven't been able to find anyone that's kind of doing multi-threading scripting there. So this could kind of be a bit of a litmus test for the industry to see how suitable multi-threaded scripting is. But yeah, I realize you're all not game developers here, so I'll clear up a few terms before I continue here. So the component model that I've been mentioning, this has been around for many years in the games industry. I've been using them professionally since 2004 at the company Chrome Studios that myself and Manu worked at in Australia. And what they are essentially is just a self-contained little object that wraps up a single piece of functionality. So if you were to think about it in terms of cars, a car engine would be a component, a wheel would be another component, a light would be a component, and so on. Now, like I was saying, in our system, they execute as what's known as tasks. So if you're not aware of that, that basically means that they need to arbitrarily execute on any thread, on any processor in a job system. No assumptions can be made about your environment outside of your own object. You need to work in this self-contained manner. And that opens up many, many doors for distributed execution. We're only worrying about running it in a single system right now, but there's no reason we can't ship off these components to the cloud and utilize cloud computing to improve our games that way. But we're not worrying about that right now. Now, we also have this concept of a blueprint. Now, the blueprint is little more than a collection of components that represent this entire object. So all of those car components I mentioned, for example, you define a car and pull in all the components you want for it. Now, it also defines the data relationship between those components so that we can schedule them in our task system correctly. It's fairly cool. The games industry as a whole is moving over to a task system. Naughty Dog has been there for a while. I believe The Last of Us shipped like that. I mean, they kind of had to because they're on PS3. But Uncharted 4, they needed to rewrite their internals to deal with it effectively. So they're already well ahead of the pack there. Now, for D to serve as a replacement for our scripting language, we kind of need to keep the scripters away from that. That's not stuff that they really need to worry about. So what we need to do is we need to give them a similar environment to the previous scripting system. And I don't mean the same language, I just mean kind of the same construction, the constructs that they work in. So all of our objects, they live inside a hierarchy inside of our levels. So that one's quite critical for their usage. It needs to be inside a hierarchy, and it needs to be each object needs to be evaluatable by name through the hierarchy. Now, each one of these objects in the hierarchy also needs to be independently scriptable. Each one can have its own unique logic that runs on it. So that's regardless of their blueprint type. There's also this concept of globally scriptable objects, which is basically a functional approach to programming. It's a function that lives somewhere, takes all its parameters, and then does stuff usually for like spawning particle effects and sounds and the like. So that's the three things that they needed preserved from the previous system. So essentially we need to give them their own self-contained environment to play in. Now, because of all the code generation I'm doing, I'm just like, this should be easy, let's do this. Yeah, we actually generate quite a bit of D code from the source data. You know, our blueprint definitions, for example, live in a JSON file. Now, this is thinking because we're doing all this code generation, right? In a Unity-esque environment, if you had your object, they call it an entity in Unity, and you wanted to resolve a component to do something specifically on it, you'd have to resolve it manually. And that'd be either calling the getComponent function or sticking it in a variable in advance somewhere. You know what? We can do better. We can go one better and create a single object representing this blueprint. So, what we do with our components that we expose from our C++ code, this is just a transform component. A transform, if you're unfamiliar, it's a position and orientation in 3D space. Now, each of our functions here, what we can do is mark it up with a new user-defined attribute that I call component script function. And this just it tells our code parser that when you're generating this scripting interface, only pay attention to those that are marked up as component script function. And you know, because us programmers are nice people, they're all written to ensure that they run great in our threaded environment. So the object itself that we generate simply comprises of pointers to the relevant components, and we generate wrapper functions for it. They don't have to worry about calling it directly. They just have to call the little wrapper function, and it's quite nice and simple to use. It's great. So the net effect, we generate the script interfaces from the definitions that the programmers themselves use, the blueprint data that everybody uses, and you know, it's all stuff that everybody's needed to use anyway, so that's removed a massive amount of maintenance from the system just from that. Cool, what's next? The level hierarchy. We need to reflect the level hierarchy in code, and this is, it's already an abstract concept or an abstract representation in the editor, so we can just go ahead and generate more code from that. So each entity in our level gets its own unique structure created for it. The name of the structure, completely unimportant, since interaction with these entities is done exclusively through the hierarchy. So being in the hierarchy, it needs access to its parent. We stick a pointer in there, give them a parent property, and they just call parent. Don't even have to worry about the messy details. There's also a bunch of other helpers in there, like I've got helper templates to iterate over all children or all children by a blueprint type. So this is far from a complete representation here. What have I got? Oh, I was highlighting the names of it as well. That is the name as you would see it in our editor, and that is the name as you would access it. It's just a normal variable. So that's quite an elegant solution there. Now, the interesting bit here is the hierarchy transform definition. So we embed a copy of this blueprint that we've generated inside it. We call it mdata, and we just alias this to it. So, the scope of the object comes entirely in, and on the little update function for its independent scripting logic that I was talking about, you don't have to worry about accessing the mdata value. It's just functions that you write like they were normal functions as if they were there defined manually. It's great. It's nice and intuitive and easy. And that's what we're looking for. All right, so that's most of what the scripters need there. But now they have this thing. They have a proper programming language and disk space, and they get something that they've wanted for a very long time, their own utility library. They can go ahead and write code and have it do whatever they want. And like I was saying previously, those utility functions, they'd have to go through the message system. So you'd have to wait for a new code build to come out, and it'd make I don't want to go into it. That system's a nightmare. Now, interestingly, they also get their own components. We have a lot of people that use Unity on the side here, so they're familiar with the component model. So I've given them their own custom scripted components, but unlike our code components, they're a fair bit more limited in scope and a lot more flexible for their needs, as it turns out. So this here is an example of a component. It just gives the entity the ability to rotate autonomously on the spot. Now, this is kind of mind-blowing code for everybody because previously, if you're all familiar with keyframing, essentially they had to create an entire animation if they wanted to do something simple like spinning a fan blade on an air conditioner. It was not in any way a good system. So this thing just automates that, and it's all done with decode. Now, there's a few things that we put into these scripted components that programmers themselves don't use. Like, they need to be able to edit the values on these components. So we give it a pretty name UDA, and it shows up in our level editor with that name on it. So okay, this is the exact set of variables I need to edit there. There's also an onUpdate event that you can add into it. It's kind of useless without the ability to execute code. So that one there goes through our threaded model. It's great. Now, what we've got here is variables that we've marked with a UDA that's called settable. And it also has a human-readable name on it, and that's the name of the variable that shows up in the level editor properties panel. And because it is a component, it also needs to be put inside a blueprint. So we've got two types of components that go into our blueprints now. We've got our code components, and we've got our scripted components. But once it's done, to get something rotating in the level on the spot, it's simply a matter of dropping the entity in the level that you want, setting the speed, and you don't have to worry about it anymore, which is an entirely better pipeline than what they were previously used to. Now, there's one little tidbit that I want to point out here. Now, see, level builders, they love degrees. Degrees are easy to understand. It's what you learn in school. Cool? But programmers, right? We know that the math functions take Radians internally. So what to do? Do we make them use Radians? Nah, probably a bad idea. They consider them unusable. So I've kind of stumbled across this pattern that I've been calling a type mimic. So this degrees object is essentially a float. It's a little more than a float. The float data inside it uses alias this, in fact. But we give it a couple of restrictions, like if you try to multiply two angles together, that's mathematically undefined, so we don't want them to do that. You can multiply by a float, though, because you're allowed to scale an angle. That's perfectly fine. The second type here is radians, and that one's kind of important because we just make all our front-facing functions, I'm using sign up here as the example, take radians instead of floats. It just kind of disappears in the compile phase because of the alias this, but it's restricted by type to Radians, which is nice. It does mean at the moment that we need to write wrapper functions for degrees to make life easier for everyone. And something came up on the news groups the other day, multiple alias this. I believe this would solve this problem, and we won't need to write these wrapper functions everywhere. So I'd be interested to see how that one goes. So we've got quite a powerful system being set up for our level builders there. It runs in our threaded environment. It's great. It doesn't, go through a VM. We've got a 2 what? 2 minutes. Good. I'm right at the end. But yeah, that's great. And because it's in Binderoo, it just handles reloading of these scripts, and that's great. One other thing I do need to get into is, I'll quickly wrap this up, memory management. Scripters, they don't need to care about memory management. You say memory management to them, and they're like, "You what, mate?" Higher level programmers expect a garbage collected environment. So, scripting languages like Python or Lua, or even languages like C# and Java, they don't make you worry about object lifetime. But we're going towards this massively parallel task-based execution environment. We can't necessarily introduce a blocking monolithic garbage collection phase. So we are pursuing arc reference counting internally, and it does kind of, it needs to be seamless to the users, collect everything, pointers, references, and slices, and to do that and let people write code without having to think about it, we've kind of needed to branch DMD to go into the front end, identify everywhere that a pointer is acquired and released, and insert new function, insert new code to handle the functions for it. So like GC obtain ref or GC release ref for that. And we're still working on it. It's not quite ready yet, and that's essentially thanks to the old cyclic reference problem. But since I've run out of time, I guess I will leave it there. I've only got a couple of extra slides, but that'll do for now. I guess we can do a couple of questions still. I've still got a couple up on the slide here. The first one is, can you have a D host? There's no reason why not. The API is just a couple of C functions that pass around everything in binary structs. As long as you can have that as a thing, it doesn't matter what language you write both the host and the client in. So that's cool. Does your current use of DLLs result in linking a copy of D runtime/Phobos and your utility library into each and every script DLL? Yes. There is a work that Benjamin's in the middle of that will fix that, so I need to work with him a bit better. I've been slack on that front, but we're definitely looking forward to that. There's another one there saying I have 5 minutes left, and that's got 2 upvotes, so cool, guys. Microphone questions maybe, if we've got time? Oh, we got one over there from Stefan.
Yeah, it's actually just a comment. First, I don't think that multiple alias this will solve your problem, because you will get into problems where the function overloading won't work. And yeah, I am also...
Yeah, it's kind of like the C++ problem, yeah.
And I'm also pretty excited to be able to solve your problem and to make your dream come true of a binding layer that works in under 20 seconds of compile time.
Yeah, the compile time at the moment for my code, it looks really simple, but it's like 16 seconds. It's kind of, yeah, it needs to be better. And I'm planning on solving that to some degree with static lib generation and incremental linking. That also kind of requires me to synthesize my own D interface files. If you use the ones provided by DMD, it doesn't expand mix-ins. And my problem is all the mix-ins that expand and execute all that compile time code. So we need to synthesize the D interfaces correctly and avoid that entire layer. You got a question here?
On the Radians versus degrees, why don't you just solve it by just taking Radians and having .deg return Radian?
I'm trying to make it so that they don't necessarily need to think about it. It's only people on the normal programmer side that care about Radians.
Sure.
Right?
Alias degrees equals Radians.
Yeah. The other thing there is that you have to be explicit about working in degrees or radians.
Right, but just use one type and have .deg return radians.
Yeah, that's...
And then call it degrees and they won't know the difference.
Yeah, I don't know.
That's what I do.
I don't know. I like having that conceptual difference between degrees and radians there, and not just having one thing solve all the things.
Well, they're dimensional, and so degrees are just a scaling factor.
Yeah, it's true. The conversion between the two is just a multiplication both ways. So, yeah, it could work. I just thought, no, we'll just make it clear that everybody's working in degrees or everybody's working in radians, not working in angles that could be both. Yeah, either or. You can do it either way.
Right at the start of your talk, you talked about the variety of platforms that you've developed for.
Yep.
So is architecture support an issue for people using D in game development? And if so, what are the architectures that you think are important to target?
The only other architecture we have to worry about these days effectively is ARM. Right, it used to be, for the last console generation, like the PlayStation 3 and the Xbox 360, they were all PowerPC at their core. So with mobile coming out there, we had to worry about x86 and x64, and ARM is version 6 and version 7, and also different kinds of PowerPC. Even Nintendo, their Wii U was a PowerPC, but they've ditched it on the Switch. It's an ARM processor now. So we only effectively need to worry about two architectures these days, x64 and ARM.
We have time for one last question.
I'm not quite clear. What are the restrictions on the C++ code? Like, can you handle templates, multiple inheritance, all the kind of more?
Yeah, well, I haven't implemented multiple inheritance yet. We've got a lot of template code that we need to expose to D as well, and I'm still working on a solution for that one specifically. Yeah, so at the moment, those are the two big restrictions.
Cool, Ethan. Thank you so much for your talk.
Thank you.
We'll take a short break, and then we have two halftime talks before our panel for the evening.